Hello gamers and developers. I just wanted to show you guys this. My virtual machine, tiny portable CPU, now has a C compiler, right? This is the work of a guy called Hadar. So this is his Discord server. Where is he? This is his account, and this one is also his account, I think. I don't know if this is his account. Anyway, he made a C compiler. Right. Here is the C compiler on GitHub. And, he made you can basically compile programs, not only standalone, like you can write an operating system, but you can also compile programs for Phobos Workstation, the operating system I wrote. Right. Hold on. I think this will build it. Okay. T to auto out T. Anyway, let's see if this builds all right. This should build the Lua bin. Right. This is a test. This is Lua modified to work for tiny portable CPU. Right, and it has software floating point and shit. So it's really cool. I haven't tested it extensively to make sure that he made all of Lua work. Like maybe the garbage collector is broken or something, but it runs commands and stuff. I don't actually remember how to program in Lua, like Lua example program. Okay, hold on. Okay, so this is a test program, right? Okay. Well, what we're gonna do is after this builds, right? We're gonna try running this. Okay, so let me fire up Phobos Workstation real quick. We're in Phobos Workstation. Okay, ed test.lua. Nope. Test.lua. Paste anyway. There we go. Right, so now we have a program written here, and it's a Lua file. Right, and we'll see if this works. The assembler is still assembling it. I did recently do some optimization of my assembler, but it still runs pretty slow. And this is a huge project, right? And so the assembler is going to I think it takes like 2 or 3 minutes. So anyway, we're running my operating system here, right? Yeah, so this is my operating system. This is the default greet, right? Oh, by the way, something I guess I should note here is it lexed it. Okay, anyway, it said I have added age verification to my OS. Right, you can set your age. So like age 26, that's my age. Right, and now there's this age file. It's 4 bytes. It stores an integer, big endian, and that's where it stores your age. You could even do like. Right, and that's totally valid. Oh, hold on. It doesn't actually tell you. Oh, man. Wait, let's set my age to the wrong number. Don't want to lie to the operating system. Anyway, so like I've added age verification to the OS, and this is a requirement for it to be legal in California. Right. Man. If only Gavin Newsom hadn't signed that bill. But anyway, so the reason I'm making this video is so that you programmers out there can write programs for my operating system, right? So basically, now that we have the C compiler doesn't actually run on the machine yet because he wrote it in Rust. But eventually, someone might use this C compiler to compile a C compiler for a TPCPU, and then we would have a working on-platform C compiler. So if you're not familiar with TPCPU already, let me tell you a little bit about TPCPU and Phobos Workstation. So basically, there is a systemic problem with software tool chains, software development tool chains, and specifically compilers, where if you get a compiler tool chain set up on one machine, it is basically impossible to perfectly replicate that compilation setup on a completely different machine. At least not without tremendous effort. All right, you have to you basically have to write a tutorial, right? And you have to use specific versions of software and stuff, and it's got all sorts of shit buried deep in the system, right? And if you want to perform the same compilation, right? Let's say you want to compile the Linux kernel for x86-64 with such and such flags. Doing that from, say, an ARM chip is going to be really hard because you have to specifically install a cross compiler, and it's crazy, right? And so I have thought that basically what we need is a CPU abstraction, right, that allows you to run development tools from any machine possible, right? And that's where Tiny Portable CPU comes in. Tiny Portable CPU is basically, it's something like a super simple Java, right? But even simpler, and the whole point is that it's simple. And I wrote an operating system for it, and basically what you can do is you can write your development tools to run inside of Tiny Portable CPU. And okay, why is this taking so long? Has it actually not been 2 minutes yet? No, it's definitely been 2 minutes. How is it taking so long? Anyway, and so currently, if I run the operating system, right, what exists right now are these programs, right? Right now I have copy, right? This copies files, new file. This dumps the environment variables. I need to type it correctly. So this is the environment variables. So if I start a new shell, right? And hold on. I can set an environment variable here, right? Because we're in a new shell. This is a built-in command in the shell. Var a 67. Vars. This is another way you can view the thing. Anyway, so now we're in the shell, right? And then this shell has this set of environment variables. If I hit Control D, now we're in this shell, and if I do vars, or dump env, right? This variable has disappeared because it only existed in that shell, right? Anyway, so right now, there's these programs. There's echo. You know what echo does probably. fhash. This just hashes a file, and so you can see if it's the same as another file. ed. That's the text editor. I wrote the text editor. It's pretty shit, but it works. It allows you to cursor around and type stuff, and you can paste stuff. I showed that on screen, right? I pasted a Lua file in. Shutdown. This shuts down the machine. Right. Then there's age. That's the thing that sets the age file. Fsize. This finds the size of the file. So if I do fsize test.lua, it should return 259. Yeah. There's com, that's the program we're running, and this is the thing that the operating system boots into. Del, that deletes a file. By the way, copy and delete are recursive. I recently made that change. AS is the assembler. So if I go in here, why is this taking so long? I thought it was faster than this. I thought it took 2 minutes. Lua is a big project, right? My assembler is not very efficiently written. The assembler is written for metaprogramming, and I didn't use hash tables or anything. It's really simple. So anyway, so the assembler allows you to TROM. Hold on, what? Oh, it evaluated all macros. Okay, so it took that long to evaluate macros. Wow. Okay, so that's what took so long. And I bet assembly is going to be really fast, because assembly should be really fast. It took 382 seconds. Oh my goodness, it's over 5 minutes. Okay, so basically, I have a standard library, but I have an assembler that runs on the machine, right? We're currently inside the editor, right? This is the text editor. It's not a clone of Unix. Oh, hold on. Okay. So now let's distro Phobos Workstation bin. Okay, now we should have Lua on the command line. Home. Ha! See, now we have Lua, right? I think this works. Hello world. Hold on, what? Okay, how do you print something? Oh, it's not io.print, it's just print. Hello world. Ah, see, it's working, right? Hold on, hold on. Okay, there. Let's try running a file. Test.lua. Cannot open test.lua. Okay, so apparently it doesn't like opening files. But you know what we can do, right? We can literally type this program in, right? So fact in if n equals 0, then return 1, else return n times fact n minus 1, end, print, enter a number. Oh shit. Okay, hold on. We need to let's do fact of 520. Is that correct? Right? Fact of 2. So this should be 2. Fact of 3. So this should be 6. Fact of 4. So that should be 24. Fact of 5. 5 times 24 is 120. Yeah. Okay. Fact of 5. Yeah. So anyway, so functions are working, right? Dot read. Um, 43. Oh, it got A, so now fact of A. Hold on, what? Oh, right, so fact of 43 is going to be too big, yeah. Oh shit, it's not reading that. A equals io dot read number 5. Fact of 5. Oh no, fact of A. Yeah, there we go. See, so say this works, right? Although apparently there's an issue with files. I don't know why files aren't working. But basically, we have Lua inside of Tiny Portable CPU now. Oh, hold on. Exit. os.exit. Exit. What? os.exit. There we go. Finally. Why didn't this one work? What is this? I typed a character 4? How did that happen? Okay, anyway, so, wait a minute. Oh, you know what it is? Oh, no, I have no idea. os.exit. What the fuck? So this one failed, but this one parsed incorrect. Okay, I don't know what happened. Anyway, we have Lua, right? That's the point. And there might have been some bugs in porting it, like for some reason it won't execute files, but you know, like it won't open test.lua for some reason, but it will, you know, Okay, so anyway, so basically you get the point, right? You can compile C programs for TPCPU, and you can compile C programs specifically. Yeah, okay. Oh, by the way, let me show you guys how big Lua is. So it's only 844K, right, for the for Lua, right? Anyway, so if you want to write programs for Phobos Workstation, if you want to make an operating system super portable, right, you can write it for TPCPU, or you can write programs for TPCPU. If you want to make your programming tools infinitely portable, you can port them to TPCPU. Anyway, so that's the video, right? I realize that it was kind of a rambly, kind of weird video, but like, you know, this is basically an announcement. TPCPU CC exists, and you know, it, and you can specify how much memory the program uses and stuff like that, right? It has float. Apparently it's software floating point. That's really weird. Okay, so he didn't make it the fixed point of the machine. He made it a software floating point. That's weird. And are linked automatically. That's interesting. So, like, you know, wait, do you have to okay, so you know what it is? These things are probably built into the compiler. Oh, that's really cool. Anyway, so this guy, he wrote a C compiler, and it's really, really cool. You know, and he committed it to the public domain. Example/part/Lua54 is MIT, right? Anyway, so he made a C compiler, and he committed it to the public domain. And if you want to use this to port programs to TPCPU, I highly encourage you to get this C compiler. I just demonstrated it runs Lua, right? So, you know. And now there's going to be tests of Lua in the repository. But anyway, so, and if you want to get TPCPU, you get it from here. You can run the emulator on Windows or Linux. You can write your own emulator, by the way, right? That's kind of part of the point, right? And there is documentation. Hold on, if I go in here, I mean, it is also in distro, but like, oh, in principle, right? I have manual pages in here, right, for the programs, and then I also have an assembler programming guide here. The examples, right, and explaining how to do stuff, right? Examples here. I don't know why I wrote hog. Why is hog? It's examples. This is something I wrote to test something. But anyway, so you can get TPCPU and you can compile C programs for it now. You should do that. Thanks for watching.